Greetings, I am Dr. N.K. Sakthivel. I would like to welcome you back to this new video session. So in this video session, I would like to focus MCQ questions of CS6801 multi-core architectures and the programming subjects. As you know, Anna University is decided to conduct end semester examination for final year students, and which will start from 22nd to 29th September 2020. It is also noticed that 1 hour long multiple choice questions examination will be conducted. So that I launched this video which will help my learners and my dear students. Especially I focus multi-core architectures and programming subjects. Reason because a few students was told that this subject is relatively tough and requesting MCQ questions. That's the reason why I would like to launch this video. So actually like this, I would like to launch the series of videos. In this video, I would like to focus Unit 1 topics as well as questions. So if my learners watch this video continuously and understand the concept and identified the answers for all the possible MCQ questions, I am sure this video will help you to get very good mark in Anna University. So with this introduction, I would like to start this session's content. Before focusing MCQ questions, I would like to highlight a few keywords. Those keywords wanted to understand and remember so that you can comfortably attend MCQ questions and you can give the correct answer. So as far as the first unit is concerned, so these are the keywords. So number 1 is Uniprocessor, and parallelly you wanted to understand parallel computing and concurrency. And then why we need what is called the parallel computing, like this, different keywords I consolidated. So all the keywords I would like to explain one by one. Then I would like to give you MCQ questions with the answer. So we will discuss each keywords one by one. First, we would like to focus what is uniprocessor. So you know a uniprocessor, or it is also called as uniprocessor system, is a system configuration whereby a single microprocessor is used to execute the task. It is very simple. As far as uniprocessor is concerned, there is only one single processor, that is called CPU, that is used to execute all the tasks. This is the oldest methodology. Nowadays we have what is called more processors, that is called multiprocessors. So that's the reason why the next keyword we focused parallel computing. Before focusing parallel computing, I would like to introduce one more keyword. Please understand, that is called parallelism. The parallelism is possible in uniprocessor system also. That means that one CPU can perform 2 or more tasks simultaneously. Then this becomes a parallelism. The tasks are not related to each other. That is very important one, because a single CPU, if executing more than one task, all the tasks should be independent tasks. That means that one task should not depend on another task. That is a small condition. So a system that processes 2 different instructions simultaneously could be considered to perform parallel processing. So this is called a parallelism, or it is also called as a parallel computing. Okay. So the parallel computing or the parallelism is nothing but a single processor executing more number of instructions simultaneously on time. That's a very important one. Only one condition here is that if more than one instructions are going to execute, all the instructions are independent among each other. That's a very important one. And one more keyword I would like to introduce, so related to parallel computing, is called multiprocessor. Okay, so multiprocessor system consists of more than one processor in a single chip, which executes more than one instructions in a single cycle. Okay, so now I introduced three keywords: uniprocessor, parallelism or parallel computing, and the third one is multiprocessor. I hope you understand the concept. And based on this, one word is called concurrency. So the concurrency, sometimes concurrency also we can expect in this university examination. Concurrency means if more than one task is executing, all the tasks can be executed parallelly, simultaneously. That is called concurrency or concurrent execution. Okay, so these words, keywords, please understand. Based on these keywords, based on this answer, we may expect some MCQ questions. Okay, the next one is the questions related to why we wanted to focus the parallel computing. So that is a very important one. The reason because so we wanted multiprocessor and very powerful processor. Reason because sometimes very complicated, toughest task has to be executed and we needed result as early as possible. For example, imagine that only a complicated task. Let us consider I am designed software for climate modeling, or that is genetic analysis, gene analysis, cancer pattern prediction, drug discovery. Like this, the numerous applications wanted computing power. For these applications, if you are using uniprocessor, so it will take a long time in terms of days, in terms of tens of hours required to complete this project. So that's the reason why we are focusing on parallel computing. That means multi-processors on time in parallel executing the task, so that the project can be executed and we will get the result. Best example, climate modeling, gene analysis, cancer pattern prediction or cancer pattern analysis, drug discovery. Like these few applications are may be considered. So for executing these applications, we wanted parallel computing. So please have in your mind this also. Okay, and that is next keyword is single core system. So you know very well the single core system is nothing but a single processor. That means single core processors have only one processor to execute all the tasks or the instructions. Single core system. That means only one CPU on the core. And another keyword is called multi-core system. So multi-core system, you know very well, from the name it is clear that in this core multi-processors are all there. For example, a core is a single processing unit. Multi-core processors have multiple processing units. Okay, so multi-core, so multiple processors or multiple CPUs. For example, you know very well dual core. So dual core, imagine that that speed is 3 gigahertz. The meaning is the processor has two processing units because it is called dual core. So two processing unit, and each unit what is called the clock speed is 3 gigahertz. Okay, like this we can understand. Similarly, sometimes we can call as 6 core, means 6 processors and all there. Like this, till now, that is 128 cores available. So this is introduction about multi-core systems. And next keyword is called task parallelism and data parallelism. So this is a very important one. You know very well what is parallelism. Here task parallelism is nothing but it is the simultaneous execution on multiple cores of many different functions across the same data set. The data set may be the same or the different, no issue. So task parallelism is nothing but simultaneous execution of multiple functions or that is multiple programs. So please understand that is called task parallelism. Okay, data parallelism means concurrent execution or the simultaneous execution of the same task of each multiple computing. Okay, so that's a very important one. So as far as task parallelism is concerned, okay, it is a different functions will be executed simultaneously. Whereas this data parallelism is concerned, okay, that is the same task is executing by different computings or different processors. Okay, so that's a very important one. As far as the data parallelism is concerned, we can call it SIMD. Okay, so that is a single instruction, multiple data stream. So we will discuss later on. So this is one of the keywords we wanted to understand in this first unit. And the second one is the load balancing. The load balancing is a very important in the parallel computing. Reason because, so the parallel computing, more processors are involving for executing a task. At that time, if one processor is overloaded, so more delay will occur. So that, okay, if more than one processors are available, each processor's load is very important one. The meaning is that, okay, equal load should be assigned to all the processors at a particular time, so that without a delay the task can be executed. So the load balancing is the subject in this research in the field of parallel computers, because simply we cannot achieve load balancing. So the idea here is, okay, if more than one processors are there, all the processors should not be overloaded. So to avoid the overloading, we have the concept called load balancing. This is one of the keywords. And the second keyword, next keyword is shared memory systems and distributed memory systems. This is a very important topic. Please note it down. Shared memory systems. Now I would like to focus. So what is shared memory systems? Shared memory systems are the shared memory multiprocessors offers a single memory space used by all processors. So shared memory systems, okay, sometimes more processors can be involved under that is a parallel computing for execution. At that time, all those processors sharing a particular memory. The meaning is that is that memory is a common for all the processors. That is called shared memory systems. In a distributed memory system, that is another one. The distributed memory systems, there is typically a processor or processors, okay, and for each processor there will be a private memory, okay, and then there is a mechanism for interconnecting and communicating between the processors. So as far as distributed memory system is concerned, for each processor there is a private memory. Then that means the processor and the memory one set for execution. Like this, okay, that is a tens of sets are available. So that is called distributed memory systems. Next keyword, processes, multitasking and threads. Okay, it's a very important concept. A small confusion may occur. Please listen my video carefully. Processes, you know very well, that is called task. Process based multitasking, okay, enable a system to execute two or more programs concurrently, then it is called process. So process is very simple. At the same time, in simultaneous manner, more than one process or more than one task going to execute, that is called process. So no doubt about that. The second one is multitasking. There is a small difference between multitasking and the threads. That's the reason I am focusing. As far as, okay, that is a thread is concerned, thread is based on multitasking enables a program to carry out two or more than two tasks in the form of threads. So very important concept, please note it down. So as far as thread is concerned, okay, that is more number of, okay, that is a task going to execute. Okay, that's a very important one. Clear? So as far as the multitasking is concerned, okay, that is more process going to execute. So that is a very important one. So please understand that is a major difference between multitasking and threads. I would like to repeat the threads once again. Thread, okay, is enable a program to carry out 2 or more tasks, okay, in the form of threads. That is called, okay, threads. Okay. So the next keyword, single instruction stream and single data stream. So this is a very simple concept we wanted to understand. So SISD, single instruction stream and single data stream. So in these MCQ questions we can expect, okay, what is abbreviation for SISD, or what do you mean by SISD, like this. Very important concept. SISD refers single instruction stream and single data stream. This SISD is a computer architecture in which a single unicore processor executes a single instruction stream to execute or to operate on a data stored in a single memory. Please understand. So SISD means single unicore and the instruction stream is single and the memory is single. Okay, then it is called SISD. And the next one is single instruction multiple data stream. So from the name you can understand that the single instruction multiple data stream, it means that single instruction stream is there and it controls many processing elements, okay, and not only that, okay, that is memory, okay, that is memory stream is multiple. Each processor has its own data memory, so that during each instruction step many sets of data are processed simultaneously. That means group of one processor, one memory, one processor, one memory. Like this, each processor has its own data memory. That's the reason why it is called multi-data stream. Single instruction stream and multi-data stream. Okay, so this is one of the concepts. Next one is scalability. So scalability is a very, very important one. The purpose is that at any cost, I should not compromise efficiency. For this purpose, we have the idea, we have the logic scalability. So for a fixed problem size, okay, it may be used to determine the optimal number of processors to be used and to maximum possible speed up that can be obtained. Okay, this is the purpose. For example, the problem size is fixed and okay, we can use a number of processors. The purpose is to achieve the maximum speed up. That means the maximum throughput, or with a short time I wanted result. For this purpose, I can use more processors, okay, on a particular problem. That's a very important one. So that is the primary objective of scalability. The problem here is, so imagine that a particular problem and I am changing the processors or number of processors, okay, continuously. At a particular time, I can get the fantastic efficiency. After that, if I am increasing more processors, I may not get efficiency. That's the reason why. So that is optimal number of processors are to be identified to solve the particular problem. With the example, I would like to explain. Suppose we run a parallel program with a fixed number of process and fixed input size. With the condition very important. So fixed number of process and fixed input size. And we obtain a particular efficiency. Let us consider E. Suppose we now increase the number of processes. Okay, and that is what is called the program also. If we can find the corresponding rate of increase in the problem size, so that the program always has the same efficiency. Understand me? So if I am increasing the processors, at the same time if I am increasing the process in a particular ratio, so that I can get the same efficiency, then it is called scalability. The meaning that, okay, at any cost to execute the particular task, okay, I can spend only 1 second. Let us consider execution time 1 second I can tolerate. If the project is so complicated, I can use the more processors, okay, so that the execution time we can retain with 1 second. If the problem is a smaller one, I can use a small minimum number of processors. So the idea is that whether the problem is complicated or the problem is simple, I wanted result within a 1 second. Okay, according to our demand, we can introduce number of processors. So that is called scalability, a very important topic in this parallel computing. It's okay. And okay, next keyword is called uniform memory access, UMA. It's a very important one. Okay, we wanted to understand what is uniform memory access. Uniform memory access is a shared memory architecture used in parallel computers. The question is very important. Whenever the question is related to uniform memory access, okay, this is for shared memory architecture under the parallel computing. So all the processors in the UMA model share the physical memory uniformly. Clear? So that is called uniform memory access. And other one is called non-uniform memory access. You can easily explain opposite to uniform memory access. So non-uniform memory access nothing but all the processors in the non-uniform memory access model, processor can access its own local memory. That means, okay, so in this non-uniform memory access, the memory won't be shared. So there is a private memory. So you can simply explain uniform memory access means the memory is a common shared by all processors. Non-uniform memory access means the private memory. So that is no processor will share the memory. Okay, so that is a difference. And the next one is distributed memory systems. I already explained to you. Here I would like to give that is a small additional input. Reason because the distributed memory system is called as cluster. That we may expect the question, why the distributed memory system, okay, it is called as cluster. Reason because you know what is a distributed memory system. Whenever we are talking about a distributed memory system, the memory system consists of, or the distributed memory system consists of a collection of PCs, that is called the computers, and the collection of Ethernets. Okay, whenever we are using, okay, the distributed memory systems, it consists of sets of PC, that means computers, and Ethernet. That the cluster is required. So that's the reason why it is called cluster. Okay, please understand. Next one is bisection bandwidth. Okay, so the bisection bandwidth, the purpose is, okay, the simultaneous connectivity is available or not. The verification is required. For example, consider two processors on time simultaneously accessing a particular data set for execution. Okay, so the two processors, what is called that connectivity should be perfect. Simultaneously, the connection should be established to both the systems, both the processors from a memory. Understand? So that is called bisection bandwidth. So as far as bisection bandwidth is concerned, please understand the status of simultaneous connectivity. So simultaneous connectivity is the keyword, what is called the meaning to understand bisection bandwidth. Next one is hypercube. You know very well hypercube. This is the topology. Okay. So what is a topology? It is a network topology used to connect multiple processors with memory models and accurately route data, so that at any cost, okay, data won't be misplaced or data won't be lost, okay, and proper connections. That is called, okay, hypercube. So hypercube is one of the network topologies. Please understand that one. In MCQ we can expect the question. And the second one is crossbar. So you know very well crossbar also, okay, that is one network model. That is sometimes we will call crossbar networks that allow any processor in the system to connect to any other processor or to any other memory unit, okay, in this proper, what is called communication channel. So without contention, that's a very important one. Here contents are referring congestion. So crossbar is the methodology by which any number of processors can contact any other processors or any other memory without congestion or without collision. Okay, for this purpose we use what is called crossbar. Okay, and next one is called the omega network. It's a very good concept. Okay, if wanted to construct complicated largest network, we can use omega network. So omega network is a network configuration. Okay, so please understand it is a network configuration and it indirect topology. Indirect topology means so between two nodes, okay, the connections wanted to establish, but not what is called direct connection. It is called shuffled interconnection. That means, for example, first particular time, let us consider A is the processor, B is the processor, and C is the processor. One time A is connected to B, another time A is connected to C. For this type of what is called establishing a connection, we can use omega network. So the idea is it is used to shuffle interconnection. Okay, at the same time 100% all the systems will be connected with omega network. So that is called omega network. And the next one is the latency and the bandwidth. You know very well the latency and bandwidth is a very important one. So as far as the latency is concerned, it is the amount of time it takes for a data to travel from one point to another. Okay, so that's a very important one. So latency is a time taken to travel a data from one point to another. Let us consider A is the sender and B is the receiver. So A, okay, going to send the data at that time, okay, the time will start, and after that B will receive the first bit. Till that time there is a one time, okay, that time is called what is called latency. Actually it is dependent on the physical distance, you know very well. Okay, so that is latency. Bandwidth is very simple. Bandwidth is the rate of data transfer for a fixed period of time. Okay, at a particular time, okay, how many packets I can transfer? 100 million bits, 1000 million bits, like this, 100 Mbps, 1000 Mbps, like this. That is called bandwidth. So this is a very important okay topic. From this topic, okay, we can expect questions. And the next one is very important concept, the speed up and the efficiency in this parallel computing. So first I would like to explain what is speed up. The speed up is defined as the ratio of the what is called serial runtime of the best sequential algorithm. I telling like this, best sequential algorithm, but for understanding purpose, okay, serial runtime to the time taken by parallel execution. Understand? The speed up is nothing but, okay, that is a time taken to execute the task in the serial manner divided by, okay, the time is required to execute the task with parallel execution. That means with more processors. One time will come, that is called speed up. Please understand. So that is a parallel computing. If more processors, okay, if you are introducing, so the execution time will be minimum, so that the speed up will be maximum. So the speed up is inversely proportional to number of processors. Please understand. And the next one is efficiency. So efficiency is nothing but speed up by processors. Okay, so this is a speed up and that is efficiency. Please understand, as far as the speed up is concerned, as the processors increased, the speed up will rise. Okay, that's a very important one. As far as efficiency is concerned, if processors and all increased, okay, that efficiency will reduce because it is inversely proportional. So speed up higher means, okay, efficiency will come down. Okay, so this is a very important topic. Okay, I couldn't explain much because with the suitable example you wanted to explain. So please understand the idea behind speed up and efficiency. We may expect important MCQ questions. And the next one is called partitioning. Okay, you know very well what is partitioning. Okay, so partitioning is nothing but, for example, if the task, okay, is a complicated task, those tasks wanted to divide it into small tasks, and the system wanted to identify the sliced tasks are independent or dependent. Okay, that is called partitioning. So partitioning means complicated task is divided into smaller tasks, and not only that, identifying those sliced tasks, okay, whether can be executed in parallel or not. The meaning that after partitioning, okay, the system will understand, okay, will predict whether all those sliced tasks are dependent or independent. Independent means, okay, parallel processing is possible. Dependent means not possible. So for this purpose, okay, we use what is called partitioning. And that another one methodology is called Foster's methodology. Okay, a very good methodology. The purpose is that, okay, is a very good methodology. I consider it is used to design and implement distributed memory systems. So to design distributed memory systems, the Foster's methodology is the key idea. Actually, it has 4 steps. Number 1 is called partitioning. Number 2 is communication. And the third one is agglomeration. And the last one is called mapping. So the 4 steps, okay, helps to construct distributed memory systems. My dear learners, okay, till now, okay, I listed few important keywords which is identified from the first unit, and briefly I explained. So all these keywords you wanted to understand, and watch this video frequently to remember the meaning of these keywords, so that the MCQ questions you can be attended. Now I would like to show some important MCQ questions on the discussed topics, and okay, we will discuss. Okay, this is a very important one. Please see. Okay, so the first unit content only I have taken. So take the first question. The first question MCQ is: computer system of a parallel computer is capable of. So wanted to identify answer. Computer system of a parallel computer is capable of what is called decentralized computing, parallel computing, centralized computing, distributed computing. Different answers. The correct answer is decentralized computing, because the parallel computer, okay, the parallel computer is capable of decentralized all the computing. Okay, this is the answer. Okay, and we will focus the second question. The second question, writing parallel programs are referred to as. For example, parallel programs is called as what? So that is called parallel programming. So the last is the correct answer. Parallel computation there. You know very well what is a computation, and a process development. Okay, this is a parallel programming. So that, okay, this answer is parallel programming. And the third question, uniprocessor computing devices are called. Okay, uniprocessor computing devices are called grid computing, centralized computing, parallel computing, and distributed computing. So which one? Centralized computing. Uniprocessor computing is a centralized computing because no parallel. Okay, a single processor. Okay, this is the answer. And the fourth question, execution of several activities at the same time is called. Okay, so it's a fourth question. It is called several activities. Execution of several activities means what? So that is a parallel. Am I correct? So that is a parallel processing. Execution of several activities at the same time is called parallel processing. Next question, dash leads to concurrency. So concurrency, you know very well, that is a parallel execution. Understand? So that is dash leads to concurrency. So obviously parallelism. So parallelism is the correct answer. And the sixth question, okay, conventional processor with one CPU is called what? Single core. Okay, no doubt about that, single core. Next one is SISD refers, I told you, SISD means so single instruction stream, single data stream. For confusion, different abbreviations you may get. Please remember, SISD refers single instruction stream and single data stream. Okay. And the next one is, what is SIMD? SIMD means single instruction, multiple data. Okay, different abbreviation, don't confuse. So this is the answer. Clear? And the ninth question, shared memory system has, it is a shared memory. Shared memory means what? So that is there is a common memory. So private memory means distributed. Okay. So for shared memory system, okay, answer is common memory. And 10th question, okay, distributed memory systems. So you know, already I told you, distributed memory system means, okay, that is a private memory. Clear? So it is a private memory. Very important concepts. Next, 11th question, UMA. I already told you, UMA means uniform memory access. Okay, uniform memory access. So other abbreviations don't confuse. Okay. Similarly, what is called uniform memory access, NUMA. Okay, so that is non-uniform memory access. So these are all expecting questions. My dear children, please watch the videos and understand everything. Okay, 12th question. And the next one is a 13th question. So that is a 13th question. Okay, distributed memory systems are called as distributed memory systems. I told you, okay, because a common processor and that is Ethernet, it's a group. That is called a distributed memory system. That's the reason why it is also called as a cluster. Okay, 13th question, answer is a cluster. 14th question, bisection width refers. So bisection means what? Okay, so for providing best connectivity simultaneously. That's a very important one. So bisection width refers status of simultaneous connectivity. Okay. And the next question, the bisection of bandwidth refers. So bandwidth is okay, very important. What's a bandwidth? Bandwidth means I got a very good bandwidth. What's the meaning? I got a very good network quality. Okay, so that is network quality is the answer. Because if I have a very good bandwidth, I will get a very good network quality. That means excellent network. Like this, you will get a comment on your mobile systems and all. The meaning is very good bandwidth is available. Okay. 16th question, hypercube. I already told you hypercube is the topology. Okay. Hypercube is the topology. And the 17th question, the bisection width of what is called a processor P cross P. Okay. The crossbar is P. Okay. So crossbar, it is a connection. And the bisection width of an omega. So I already told you omega means, okay, so that is efficient connection in partial, okay, part. So that's the reason why P by 2. Answer is P by 2. Omega network, okay, one direction, one side is connected to another side. It's 50%, that is P by 2. Okay, for 17th question, P by 2. And the next question is latency. So I told you latency is nothing but time between source and destination before sending and first reaching. So see, this is the answer. Time that elapses between sources beginning the data and first bit reaching a destination. Because first bit is very important. That is called latency. Okay, this is the answer. Clear? And okay, that is the 19th question. Okay, speed up. So I told you speed up means, okay, that is a numerator, okay, serial or sequence, and the denominator with more processor, that is called parallel. That is a serial time execution by parallel time execution. So this is the speed up. First is the correct answer. And 20th, the efficiencies. Okay, efficiency of the parallel programming will increase. When the efficiency will increase, okay, number of processors decreased. That is a very important one. Please note it down. From the formula you can understand, but here I didn't show the formula. So efficiency of the parallel program, okay, inversely proportional to number of processors. So that, okay, if you wanted to increase the efficiency and you wanted to reduce what is called processors, okay, is the 20th question. And the 21st question, okay, that is a speed up. Okay, speed up of parallel program will increase. Okay, what happened? Number of processors also increased. Clear? As far as speed up is concerned, okay, if more speed, more processor. Efficiency is inversely proportional to speed up. That's the reason why both the answers, okay, questions understand, and the reason for answer also explained. Okay, you understand. 22nd question. The program is scalable. What is the meaning of scalable? Efficiency should not be compromised. If a program is going high, more processor. Program is small one, less processor. So at any cost, I should not compromise efficiency. So okay, 22nd scalable answer is efficiency of the program will decrease for less processors. Okay, this is the answer. Clear? And 23rd question. Partitioning in parallel computing is used for, I told you what is partitioning. For what purpose? Executing task in parallel. That's a very important one. Okay, that is after partitioning, we will identify what are the tasks are independent one, and those independent tasks can be executed in parallel. That's the reason why the partitioning purpose is for executing the task in parallel. Okay. 24th question. The concurrent execution of multiple tasks in a single user system is called as what? So that is concurrent execution means multi. Okay, multiple tasks, already that question is here. So that answer is multitasking. Okay, so that is 24th question over. And the last question, 25th question. Name the methodology which is used to implement parallelism in distributed memory system. So which methodology helped to implement parallelism in distributed system? Foster's methodology. Okay, the Foster's methodology. My dear learners, my dear students, I demonstrated the very important keywords associated with the first unit of this topic, and based on the topics I coined 25 MCQ questions, and I have given that is answer with the explanation. So I would like to advise, request all my learners and my dear children, watch this video frequently and understand the concept and find the correct answer for all the 25 questions. So what I planned for each unit, okay, I would like to identify 25 MCQ questions, and those questions will be explained like this for all the 5 units. So today I launched this video. So within 2 or 3 days I would like to launch, that is a video for the second unit and this third unit, so on and so forth. Okay, my dear learners, I thank you very much for watching this what is called video. Okay, understand the concept and get the highest mark. Thank you very much for watching this video. So I would like to advise my dear learners, so for getting notification for the further my videos, when I upload you will get a notification. For this, better you can subscribe this channel, and if you are willing, I request you to like this video also. Thank you very much for watching this video. Thank you very much. Bye.